there. Today I'm going to try to make a zinc bromide flow cell. What we have here is 2 plates of stainless steel 316. I did try to tap the holes with a 2mm tap, but impossible. I broke all my drill bits just trying to drill the 1.6mm hole required, so I bolted them and siliconed them up for now. What you'd probably want to do is just weld these up that way. These are to hold the carbon activated material onto the collector plate. These are those redhead fire bricks what go into the kiln with the feather carbon just to keep the oxygen out. And what I did here was, after I kilned them, I crushed them down, mixed them with dextrin made from corn flour, made up a putty, squashed them in my mould. They had a little tab, I just chopped that off so it fits in the flow cell. And their resistance on the stainless steel collectors, it's on the 200 range. There's 1.5 and 1.43. That one turned out a bit better. I think that was on the outside of the furnace, my crucible. Where this one was more, I had a group of them stacked together for a trial. The dextrin ones were the only ones that sort of survived. You can sort of see they cracked still. But it's a work in progress. Maybe I didn't add enough dextrin to the mix. I might try again later, not now, but sometime. So what the cell will be made up of is, you have to use the 316 or the 304 will just rust out. So we'll have the current collector, which is the stainless steel outer casing, the active material. I used a bit of breadboard, drilled some holes in the end for the electrolyte to go in and out. I glued them in with some iodide, so you'd get a layer of that. Then some perspex, what will go on there, and then the membrane, which is a cellulose acetate coated paper towel for now, would be on top of that, sandwiched between the other plate. I'll use silicone because it doesn't leak through this paper, because I tried it on those little Tic Tac containers. Like that one there, that hasn't leaked. That's got a hole in the center, and the paper towel with the binder around it is hanging out the outside. It's been like that for years now. And then you put the other one on, and then the other current collector goes on, so we end up with like a little sandwich. There is some other things I might try later. I might also make the current collector so I don't have to drill through the stainless steel, fit on the inside, and just have these holes drilled, 3, because 316, if you ever tried drilling through 316, you like get 2 holes if you're lucky with your drill bit, then you have to sharpen it. So it's quite tricky. I'm waiting on my zinc bromide still. I had an 8-week wait to have it made. It's 98%. If I wanted the 99%, it was going to cost $290 for 500 grams, where I got 300 grams, which will just a little bit more than you need for 1 mole solution for 1 litre. I'm going to try 2 tanks, 500 mils each. I'm going to use these little pumps I happened to buy for the Peltier thing to pump the electrolyte. The only thing I'm going to have to do is, on the charge cycle, the pump will have to sit sort of higher up on the tank, and then when we discharge it, we'll just lower it down into the zinc bromide, into the bromide, and that should sort of work. I also managed to time it well and bought some of these. This is an adjustable voltage and adjustable constant current step down buck converter. You can buy them for $4, or you can't get them now because they're in China. This was outside Taiwan. I had this outside for over 3 weeks when the package came, because it was sort of in the outbreak period. So that was out in the sun. We had like 36, 37 degree days. So I'm pretty sure this does not have any virus on it now, or it wouldn't be in here. And plus it's already been in the house for 2 weeks and I'm fine. But you can't get them now. Well, not from there anyway. So you're going to have trouble getting them. And I made it so it was bolt-on attachments, so we could try the carbon felt. I've had this for ages, well over a year. I just didn't want to use it yet. So the carbon felt will be sort of, if this one, we'll see how this carbon chip goes. But I'm thinking the carbon felt with the zinc hexacyanoferrate coated on one of them, and iron 3 hexacyano coated on the next one will be even better, maybe. But we'll start off with this base version of the cell, which should hopefully work. Oh yeah, and another thing why I got that, because I got to drive 2 pumps at 3 volts off of a 12 volt battery. So this will allow me to take in 12 volts, step it down to 3 volts, adjust the current to only like 200 milliamps, and have the output drive the 2 motors, which will pump the solution around for a while, which will be interesting. So I'm going to start assembling this because I want to have the silicon all dried, and this has got to be washed through the membrane, and it also has to soak up some water for a while, just so we can sort of get used to it, so the electrons can flow, ions we want through there, not electrons, or a leak. So I'm not sure how it's going to work, but the coating's not too bad. It's just what's coated on one side, it goes through. It actually toughens up the paper towel a bit. You can sort of feel it being a bit of a flexible plastic. I don't want to stretch it because you can see it stretching. Yeah, so these ones were a bit of breadboard from the cheap shop, which wasn't too cheap. So breadboard's like $20, but I needed the thickness to cover up that thickness, and then the gap between the bolt heads is just under the membrane, so it shouldn't be a problem. Hopefully they don't leak. They've been well siliconed, but yeah, didn't feel like doing the welding yet on the test one because I want to pull it apart and everything. So you'd have the thread coming up this way and just a nut to hold your electrode on. And then you'd chop off the remainder and make it flush so it doesn't poke through the thing. So, a bit of luck, the zinc bromide flow cell will actually produce some power. Fingers crossed. But we're a few weeks away from that yet.